Okay, hi there. E is equal to mc squared calculations. So let's have a look. Right, first thing you need to do is get your tables, page 46, and we have more information in the tables that will be useful to us. Okay, so we have the mass of the alpha particle, we already have the electron mass, okay, and we now have the neutron mass, or sorry, the neutron mass, and on the following page we have the proton mass, okay, and instead of speed of light, obviously, which we'll be using. So we have the four masses of the proton, the neutron, the electron, and the alpha particle. So you won't be given those in exam questions. You'll have to find them. They're to 7 decimal places, but we will use, this is a case where we have to use a lot of decimal places, and we follow what is asked in the question. Okay, in this case, if you look, you're given the lithium mass to 6 decimal places, so that's what we're going to do. Okay, so we've just looked at this this particular interaction. So lithium, now it should say lithium 7, okay, is bombarded with a proton, 2 alpha particles are produced. So we'll write down the nuclear equation again. So lithium 7 plus a proton, giving you 2 alpha particles, plus your energy. Okay, now we're asked to give an answer in joules and mega electron volts. We look at the mega electron volts later. Okay, so remember we said mass before. Okay, first of all, we're going to get the mass after. We're going to get the mass defect, which is the loss in mass, and then we're going to get the energy. And there are the 4 points. 1, 2, 3, 4. Follow them through. 1, 2, 3, 4. Okay. So the mass before, we're given the lithium mass 1.165007 by 10 to the minus 26 plus the proton mass, which we find from our tables. Okay, so 1.673493 by 10 to the minus 27. Okay, and we're going to add the two of those together, and we get 1.332356 by 10 to the 26 kilograms. Sorry, minus 26 kilograms. Mass before. Mass after the alpha particle. So 6.646322 by 10 to the minus 27 multiplied by 2. So 2. Okay, so we get 1.329264. Sorry, 264 by 10 to the minus 26. Okay, and you notice there's been a loss of mass. So we need to find the loss of mass. So we get the mass before, and we subtract the mass after. Sorry. Mass before minus mass after. Okay, and we end up getting 3.092 by 10 to the minus 29. Okay, so we've gone out to 3 decimal places because we've gone from 10 to minus 26 to 10 to minus 29. So don't worry about that. Okay, we just to continue as we are. Right. So now we need to get the energy. So this is your loss in mass. That mass has changed into energy, so we use E is equal to mc squared. Okay, so the mass is 3.092 by 10 to the minus 29, and we're going to put in C from our tables. Okay, and we're now at 3 decimal places, so we'll get C at 3 decimal places, so 2.998 by 10 to the power of 8 squared. Okay, and we get an answer of 2.783 by 10 to the minus 12 joules. And that's your answer. So 4 steps. Get the mass before, just add the 2 masses. Get the mass after, add the 2 masses. Find the loss in mass by subtracting, and then convert the mass into energy using E is equal to mc squared. And we got our answer in joules. Okay, everything's in joules. It went in kilograms, comes out in joules. All right. Now you're then asked to change to a mega electron volts. Now this is often asked, okay, because mega electron volt is usually the unit that's used in these kind of interactions. So remember how we change. Okay, so to change to electron volts, and some of us got this wrong when we were doing it the last time, you just get your 2.783 by 10 to the minus 12, and you divide it by the charge on the electron, so 1.602, that multiplied by 10 to the minus 19. And you get an answer when you do that of 1.739 by 10 to the power 7 electron volts. Okay. Now to change to mega, if you're doing it, okay, mega is a million, so you're going to divide by a million to find out how many mega electron volts, or what we actually do to change to mega electron volts. Probably the easiest way of doing it is just divide by 10 to the power 6, which is a million. Divide by the mega. Okay, and you end up getting an answer of 17.39 mega electron volts. And you see this number is a reasonable number. It makes much more sense and easier to compare from other values than this 3.092 by 10 to the minus 29. Okay. Alternatively here, what some people do, and what I actually do myself, is you could write it as electron volts, and then you just rewrite your scientific notation as a 10 to the power 6 and a 10 to the power 1 electron volts. You know the 10 to the power 6 is mega. So instead of the 10 to the power 6, you're putting in your mega, and then obviously that becomes 17.39 mega electron volts. I actually prefer that method, but most people use that method. Okay, thanks man.